Yes. Okay. Okay. Good evening, everybody. I started the recording of this section, and so that you can come back and review it whenever need be. I will take this approach that we will go through homework and then do it in the backward way, and then we come back and see anything missing that we need to cover. All right. Because this way we won't be missing out anything on the homework while we finish the lecture within our time frame. All right. Let me see. First, let me also share my screen with you. Yeah. Okay. So I'm sharing my screen with you now, and hope you can also. Can you see the screen I'm sharing? If not, let me know. You should be able to see it.
I see it.
Me too.
Yeah. Okay. Okay. Very good. All right. What we are going to enter in this section is the descriptive statistics, and we should be. I think we have covered the. Let's come back to the module 2, and take a quick look at the content we are about to enter this week, where we have. If you click on the module 2, you will see the overview. Okay, where in this overview, we see that we are getting into descriptive statistic. And the descriptive statistic, the most important ones include mean, median, mode, standard deviation, variance, quartile, and percentiles, etc. And these are basic and most important. We use this from day-to-day basis. Okay, average speed, the median ranking, the percentile, and so on and so forth, in every aspect of our daily life. Okay, and some also graphical method, Boxplot, will also be studied. So we'll get into this as much as we can. And also, when we learn the descriptive statistic, to describe these 5 things that we are mostly interested, they include center, variability, probability, shape, and outliers. Okay, center are described by mean, median, mode. These are the 3 most commonly used measure for center, and there are pros and cons for them. Then sometimes we prefer to use mean to median and mode. Sometimes we prefer median. That depends on how the distribution of our data. In general, the most popular one is mean. Okay. Then, with respect to mean, we can describe the deviation. So here, which accounts for the variability. Okay, standard deviation is actually the a measure for the average distances deviations from the center, which is the mean. Okay, and there are different formulas which you will see in the PowerPoint, and that we will come back and take a quick look at them after we finish covering the assignments. Then once you have actually to have the standard deviation, you need to calculate the variance first. Once you have the variance, you will be able to take the square root of it and get the standard deviation. A variance is a byproduct on your way of getting standard deviation. Okay, and it's very useful later, as we will see. We use variance to estimate the mean, to make inferences about the mean. Okay, and then quartile, they are also relative positions to describe the data, and percentiles. Actually, quartiles are what? The 25th, 50th, and 75th percentiles. Think of $1. $1 has 100 cents. So a quarter is 25 cents. A quarter is 25 cents. 1 cent is similar to percentile, and a quarter is like 1 quartile. And if you have two quarters, that means you have 50 cents, 50 percentile, and that's 2 quarters, the second quartile. And if you have 3 quarters, that means you have 75%, and that's equivalent to the 75th percentile, and that's third quartile. If you have $1, then you have the maximum, which is the 4th quartile. Okay, and that's 100 percentile as well. Okay, so this, and then Boxplot. In the Boxplot, you have a 5 summary number, which is the 4 quartiles. Actually, minimum, first quartile, median, third quartile, and maximum. These are the 5 summary numbers. Okay, then in addition to that, we will learn Chebyshev and empirical rule to describe probability. So in this section, we and then in a box plot, we can also be used to. It can be also used to determine the outliers. Okay, so in this section, in this module, we shall learn graphical way and numerical way to describe data that covers the center, variability, probability, shape, and outlier. Okay, these are the 5 areas that we are mostly interested in knowing when you are to describe data. To describe data, you have to describe data in these regards. Okay, all right, so that gives you an overview of the class today. Then as I mentioned, we will come back and look at the lecture file, PowerPoint. Okay, now first let's go to the assignments. Okay, the assignments. Assignment 2 covering chapter 3, and I only use 7 questions here, so this course is not too heavy, so not too time consuming, while you still can practice what you learn in the lecture. Okay, doable for you. Okay, the first question is, to the data below are the frequency and the cremation burials found in 17 archaeological sites. Obtain the mean, median, and modes of these data. Which measure of center do you think they are? Okay, so you have these numbers. How do you find the mean? Oh, okay, it's the average. So you should click on this and open this data set in Excel. Okay, you open it in Excel. They will be here. So the way to find, actually, although it only asks you to find a mean, you actually could use what? You could use, let me delete some of the data here, and then do it this way. Go to add in. I believe you all have installed the statistic Toolpak. If not, let me show it once again very quickly for you. File, options, add-ins, Toolpak, go. Make sure at least the first one you check. I don't mind you check all of them. You get more functions, which you may not need right now, but useful in the future. Okay, so then you can click on data, and it's under data analysis. It's called data analysis Toolpak. And as you can see, you have a sufficient amount of functions for you to use, at least suffice for this class. Okay, then you click on Descriptive Statistics, okay. And input range, just move your cursor to select all of them. You can see A1 to A8. Then it's on the same column. There's no label, so you don't check the label. If you check the label, the first number 81 will become the label. So you will have one less observation. So that's not accurate. Oh, sorry. No, let me do it again. Okay. All right. And then I choose to post it on the same page, and let me put it here. Okay. Oh, summary statistic. Summary statistic. I think that's good enough. Okay, so here you can see what? Mean, median, and mode. Obviously, there is no mode because everyone appear only once. So it says not available. So you can see with one click, I have all the three measures for center. Then I have standard deviation. We'll talk about standard error in the future. Okay, first let's look at standard deviation. Make sure you know that this is sample standard deviation. Sample STDV. And this is sample variance. I should have shown you that the result for sample standard deviation is different from the population standard deviation, because if you use STDV, you see there's a .p and .s. .s is for sample standard deviation, .p is for population standard deviation, and two, they give you different results. Okay, as you can see, they give you different results, right? You see different. Okay, so make sure you know that, and we are just treating these toy data set as a toy example. So we treat them as a sample, not population. Population is usually a very large data set, include the whole population. Okay, huge population. Whenever you hear the term population, it should be what, at least 20 times or more the size of the sample. Okay, and then sample variance as well. And you can see the variance is the square root of standard deviation is the square root of population standard deviations. Okay. Maybe I should introduce a little bit how do you get the standard deviation. Of course, I didn't cover it in the I haven't covered like a theory or official formula way, but let me show it to you. First, you calculate the mean. Okay, of course you got a mean here. So once you calculate the mean, then you calculate everyone's deviation from the center. Okay, so how do you calculate that? Let me a second. Okay, insert. Okay, so as I mentioned, the deviation, once you get the center mean, we want to see everybody's deviation with respect to it. So I want to see how far away is 81 from the mean right here. Okay, I find a difference, but I have to lock the this mean, which by I can, 1 second. Usually I can do it by, just 1 second. Okay, I can click on, I type lock, okay, because I want to use copy, so if you don't lock it, you will keep scrolling down. To make sure when I make copies, it's still F5 for this min, okay? So you see that negative, scroll it down. So you see all the deviations right here from the center. Some are negative, some are positive. And if you don't, but then we don't want the negative, because otherwise, if you take the sum of them, it will become what? If you take the sum of these, it will become what? 0. And that means there's no deviation from the center. It's impossible. So that's not correct. So you have to square the differences, the deviations. So let's do this for all of them, and then take the sum. Okay, take the sum of all of them, then divide this sum, and divide this sum by what? Divide this sum by the number. There are 8 of them, and then divide that number by 8 minus 1. Okay, 8 minus 1, because that's the formula, okay? And so that's a what? Variance. You get the variance. Now, so through the variance, you can calculate standard deviation, sample standard deviation, sample. Is what? Is this divided by, square root SQRT excuse me. So can you now compare them with the result here? 174.0895 and then 303.0714. They're exactly the same. So now you see how variance and standard deviation, sample variance and sample standard deviation is calculated. And if you divide that this number by n, not n is 8, and then take the square root of it by, you will get the result for population standard deviation, which is you see 162.845. You see, this is population standard deviation. Okay, so now you see how these things come about. Okay, and not just know the formula. All right, so so this is how do you calculate them. All right, now I have to go back to here. So that being said, you have all the answers already. And what measures do you think is the works the best here? If the data is more symmetric, then use the mean. If the data is skewed very much to the right or to the left, then maybe median is better, because median is robust to more extreme outliers. When they are extreme values, then probably median is preferred. And from the observation here, you can see there is a very big number, 2167, which is obviously by visualization, you can see that's an outlier. So I will guess that you would prefer median. Okay, next question. How do you calculate a range? Okay, do the same thing similar to this, what I did, and you will see the range. How do you get the range? You can calculate, use range, right? Range, and well, wait a minute. Maybe there's not such a function. There's not such a function. So what you need to do is to calculate maximum of this, and minus the minimum of that, you'll get the range. Okay, minus the minimum of minus. Okay, you see? So that's a range. You get it. And standard deviation, you can calculate all of them, and standard deviation the way I did for the first question. And quartiles, okay, for Q1, Q2, Q3 is the first quartile, second quartile, and third quartile. That means it's a 25th percentile, 50th percentile, and 75th percentile. The way to calculate it is also easy. You can use Excel, and then to calculate what? The Q1 equal to what? Use quartile. You see quartile, and quartile EXC is exclusive. That means you exclude the for maximum and minimum. So we just use the what? Include is included both of them. Okay. Normally it should be included. This is the, okay, you select a range and comma, and then find what? 1 is the first quartile. You see the 25th percentile, right? And then median is the 50th percentile. Third quartile is the 75th percentile. Okay, then you plug in 1. Okay, but I will do, what I will do is to click on, what I will do is click on F, you could function key 4. Okay, function key F4, you will be able to add the $sign. Why do I do this $sign? Because I want to make copies. Okay, and then Q2 and Q3. All right, so now I can make copies, and then change the values to 2, change the value to 3. So I got the Q1, Q2, Q3. All right, easy. Also, you can calculate that, or percentile. Percentile also included, okay, and then select the array, comma, the K is what? K is, for example, 25th percentile, it type 25. Oh, sorry, it should be, K should be 0.25. So you can see you get the same number, and so on and so forth. The standardized version of X. Okay, what is the Z? Z is a relative. Z is a relative scores, which is Z equal to X minus mu divided by sigma. That means X minus mean divided by standard deviation. Okay. So this is a formula. Okay. So with that formula, you standardize it. And so with that, how do you calculate the standardized value for X? So you have to use this formula, and then first find what's the mean, and then what's the standard deviation. Then plug them in, plug X, mean, and STDV into this formula, you'll get that Z with respect to that X value. So in this case, your mean is 693, STDV 0.76. So what's the standardized value of X? That is find the standardized version of X. Okay, you need to plug in the formula you can use this X minus mean, right? You plug in that mean, and then what's the standard deviation? Just plug them in. That will be the answer. And then the interpret Z value for 7.7 and 5.7. Then you just plug those in numbers into the formula twice. You get 2 Z values. That will be it. All right, easy. Okay. Okay, then a survey track a national representative. Okay, so for this question, we are talking about, we want to cover the Chebyshev Rule. What does Chebyshev Rule says? For that, we need to come back and take a quick look at the PowerPoint. In the PowerPoint, we shall see Chebyshev Rule. Chebyshev Rule says, okay, yeah, you can, by the way, you can come back and see what the formula I used to match what I say. Okay, actually what I say can be confirmed and verified. Double check here to what? To find the theoretical support. Okay, what I said. Yeah, okay. Let me first look at the Chebyshev Rule. Once you find the center, once you find the standard deviation, here comes in the Chebyshev Rule to estimate the probability, which we use to describe the data. That means for any quantitative data set and for any number k greater than or equal to 1, at least 1 minus 1 over k square of the observation lie within k standard deviations to either side of the mean. That is between center minus k times standard deviation, center plus k times standard deviation. Okay, so for example, so in this case, now here we see we want the A-ninth. A-ninth is what? A-ninth is 1 minus 1 over 9. That means that's equal to 1 minus 1 over 3 square. So you compare that with this formula, 1 minus 1 over 3 square, that means k is 3. So in order to answer this question, we actually need to calculate the interval that's between x minus 3 times standard deviation plus x bar plus 3 times s, that interval. And we were giving x bar, we were giving s. Now we got the k from the A-ninth through this formula. We can calculate that interval. All right. So hope that you got it now. So so where you have for the 265 students, mean and standard math scores. So math, obviously you have x bar is 24 and then s is 65. So what you should do is 24 and 65, your x bar minus k is 3 s equal to what? 24 minus 3 times what? 65. Enter, you will get the answer. And then what's the upper bound? Plus. You just change the minus to plus. You will get the answers. Okay? I will let you do it yourself. Very easy. So, but then once you get the interval, what do you get? You can say, okay, I can say with confidence, I mean with without fail, because this is a theory that can be proved, that A over 9 or equivalent to 88.9% of the data fall within the interval that you just calculated based on that formula. Okay, so, and that's question A. And then question B, you do the same thing, only change X bar to 3 and S to 49. Plug in the same formula using the same K, you get the answer. That's Chebyshev. All right. Okay, so now A through quantitative data set. Okay, what's a 50th percentile? Remember what I said. Consider you have $1, so 50 percentile is like you have 2 quarters. And what is 2 quarters? 2 quarters is 50th percentile, right? It is the 50th percentile. Let me see what. Okay, 50th percentile, and that's equal to what? Median. Okay, QL is upper quartile, which is third quartile. QU, lower, Q lower is a lower quartile, and Q is upper quartile, which means QL is Q3. QL is Q1. QU is Q3. QL is Q1 is 25th percentile. QU is Q3 is 75th percentile. You can use the formula I show you here, right here, to calculate them. Okay, not difficult. All right, this is for a scattergram. Let's look at the table. Okay, obviously you have number of strike, age of fish. The more the number of strike, the more fish is probably, or vice versa. You have to look at the data. Okay, this is in experiment. Anyway, there's a relationship between these two data sets. So we may open this data set in Excel, and then what? I will delete this and then work out a little bit. So let's select the 2 column, okay, here, and then insert, and then choose the what? Scatterplot. And you can see that as number of strikes increase, it looks like the age of fish decrease. I didn't use the whole data set, so I can't say for sure, but you will be able to determine it with yourself. So then you can compare your result with it. All right. Yeah, that's it. I wonder why I didn't choose a box plot, but no worries. If you are to plot a box plot, which is very, very useful, what you can do is you can install the what do you call it, another software as add-in, okay. Another software which is called Real Statistic. That is the software's name. But And that's very useful. Okay, let me see if you can download it here. You go to realstatistic.com, and then real statistic, once realstatistic.com. Okay, I'll send that to you. Let me chat realfix.com. Okay, then you can download it and install it. It's free. Okay, free download. So you can download it. There are way more than you will need. Okay, you can download it here. For free. 1 second. The first Excel books workbook. No. Let me see. Where did I download it? Download. Download. Yeah. 1 second. Free download, free reels. Yeah. Oh, no, not provided by Excel. The company Excel provide. Okay. Download this one. Resources pack. Okay, right. Here within, now we explain how to download it with this. Okay. Okay, download here. Download right here. 2016. Let's give it a try. All right, so you get it here. And now you should be able to, let's execute it. Enable macro. Hopefully, and then let's go to options, add-ins, real statistics. Real statistics. Yeah, sometimes it's not easy to find. It's not installed properly, but there should be a way to install it. Let me figure this the problem. Usually, yeah, there could be some issue in installing it. That's wrong. Okay. Yeah. I successfully installed it before, but not every time when you change a computer. Okay. Anyway, and then you open options, add-ins. Yeah, it's not installed in a place where it's supposed to be, or you need to copy and paste it to this location. So when you open it, you'll be able to find it to install it. Anyway, I may find the way to do it, then you can follow it to have this. Anyway, my point is that you can install the, you can plot the Boxplot. Okay, let me go quickly over the Boxplot, then we can end the meeting today. The Boxplot, Boxplot is right here, in which you will see the 5 summary numbers. 5 summary numbers. I don't see the graph here yet. Okay, right here. Where's the graph? Boxplot. Okay. The box. Or maybe I'll just use a box here. The box here. Okay. Look, this is the Q1. Sorry, this is the minimum. Q1, Q2, Q3, maximum. Okay, 5 summary numbers. But usually, if you have outlier, then outlier should be either minimum or maximum. Maximum on this side, on the right-hand side, on the upper side, minimum on the left-hand side. Okay, so when you have those, as you can see, you see Q1 correspond to the lower end of the box, Q2 is median, and Q3 is the 75th percentile, and so on and so forth. And then how do you build we call this whisker. How do you build the whisker? Whisker is the line that connecting the Q1 to the minimum within the lower fence. What is a fence? A fence is built by extending from Q1 to 1.5 times IQR. What is IQR? IQR, you see the lower limit, Q1 minus 1.5 IQR. Upper limit is Q3 plus 1.5 IQR. What is IQR? IQR is Q3 minus Q1. Q3 minus Q1. Q3 minus Q1 gives you IQR. Then based on IQR, you can build the fences. So from here, Q3 plus 1.5 times IQR, the fences should be here. Since there's no values greater than that, there's no upper fence. There's no outlier on the right-hand side. And then you build is minus 1.5 IQR from Q1. You can build the lower fences in the same way, but there's no lower value than that outside of that fence, so there's no outliers. But here we have an outlier because it lies outside of the upper fence, which is Q3 plus 1.5 times IQR. Okay, so this is the 5 summary numbers, and with which you can build a box plot and to identify the outlier. Okay, and I think I basically cover these important materials for you, except that you don't have an easier way to construct a box plot. But if you search in the Excel tutorial, you should be able to find how to construct it in a way that's not that quick, but still you can do it. Okay, I will figure out how to exactly install real estate for you. Okay, or you can use R to construct a box plot, which is very easy. Okay, you can do it that way. Okay, all right. Okay, I think it's a good point to stop. Let me see if any question here. Okay, let me stop sharing. Okay. All right. Do we have any questions before we dismiss? Oh, any questions, Helena and Yvette?
I'm good. Thank you.
Okay. Okay. Very
No
good.
questions.
All good, right, Helena?
Yes, all good.
Okay. All right. Very good. Okay. So I think we can stop here. It's very nice meeting you tonight, and I wish you have a very good night. Okay. And
Good night.
don't hesitate to let me know whenever you have any questions. Post that in the discussion. I will be glad to help you out. Okay. All right.
Thank you.
Bye. Thank you.
Bye.